My name is Julian. I'm on a team with Vedant, Aiden, Griffith, and Brandon, and our project proposal is to apply deep reinforcement learning to the stock market. So, as an introduction, the stock market has a lot of data, which is really hard to analyze because so many different factors can contribute to the price of a stock. A lot of people have tried to beat the stock market using a multitude of different methods, such as linear regression. Our team hopes to create a product that can simplify portfolio management and give people easy access to the investment world. That leads us to the problem statement for this project, which is utilizing deep reinforcement learning for stocks. Our main objective is to return consistent positive returns, and our stretch goal is to outperform other methods such as investing in ETFs or individual stocks.
So most stock tools that exist today rely mostly on traditional machine learning methods. For example, logistic regression, classifications and regression trees, and whatnot. Now, what we seek to do is, rather than using these, we want to use deep reinforcement learning. Now, normal reinforcement learning is a very powerful tool and usually yields very great results. However, we have an issue with higher dimensionality data. It tends to break down and not be as effective. Thus, people have started using deep learning methods in reinforcement learning to help account for this higher dimensionality while still yielding great results. Since we have stock data, and stock data has very high dimensionality, we see that this would be a very viable solution. So we wish to attack the stock problem using deep reinforcement learning. So we will use historical data for the stocks as our training data, except we'll save 1 to 2 years or so just to test it on because we don't want no data left for us to test on. We don't want to test on our training data. That'd be very useless. And lastly, for our model, we're going to use optimal actor-critic strategies. So the main goal of our project is to create predictions that'll ultimately lead to positive returns, hopefully better than some of the previously mentioned methods for investing. Secondly, we hope to create a model that, as things change in the future, because the stock market is a very volatile field, so some different factors can affect stocks differently in the future than they do now. So hopefully, our model is able to adapt to that and still consistently create positive returns.
So our team members for this project are Vedant as a machine learning engineer, Aiden as a data scientist and web developer, Julian as a tech lead, Brandon, which is me, as a software developer, and Griffith as a scrum master and project manager. So here's our proposed timeline for the project over the rest of the semester. We start with our proposal, finishing around late October, and our data selection will last all of October. We'll be doing our data cleanup late October, and model design will start late October and progress around halfway into November. And then our programming phase, which will likely be one of the more heavy phases, will be also lasting until mid-November. Then we will be working on training and deploying the model, and the midterm report, testing and refining, and finally the final report.